Okay, so this is lesson 2.2.1 or 2.2.1's review and preview. I always get mixed up with all those numbers. And this is 2-81. This is the very first one, and they've given us an E tool to use. So we're just going to solve the whole thing in the E tool, and we'll talk about it as we go. So let's just jump in. While watering her outdoor plants, Maura noticed that the water coming out of her garden hose followed a parabolic path. Thinking that she might be able to model the path of the water with an equation, she quickly took some measurements. The highest point the water reached was 8 feet, and it landed on the plants 10 feet from where she was standing. Both the nozzle of the hose and the top of the flowers were 4 feet above the ground. Help Maura write an equation that describes the path of the water from the hose to the top of her plants. What domain and range makes sense for the model? Move sliders H and K. So that's what we're going to do. We're going to move sliders. Now you can move this anywhere. Some people can just go ahead and do this and go to the point of origin, and then they would have their vertex at 5, 8. Okay, that's fine. I like to take it at the point of origin. And so I'm just going to go ahead and move it also over because I like to, I don't know, there's something about the line they've drawn for X and Y, and it's just nice right angle there for me to check out. So now I think the vertex is at, so we're going to come down here and figure out the vertex first. I believe it is at 0, 8 for this scenario, the way we did the points. So 0, 8. Okay. And that's our vertex. So I'm going to go ahead and label it as such. Okay. Now, what I need to do is now figure out my equation. Well, my parabola that I'm going to have is going to be opening downwards. So I'm going to start with a negative in front of the parentheses. I know I'm going to have to change it, but it's going to be a negative A. So, and then what I'm going to do is let's just put the A in there and see if it gives us a slider. And I'm going to go X minus 0 because we are at the point of origin. And I'm going to delete all that. Then we're going to come out here and we're going to square it. Okay, and then we're going to add 8. Okay, all right, so we've got our little slider there, so we'll see how much that helps us, okay? So we're going to add it. Okay, so let's just see what happens as I go through it. So I'm going to go ahead. I need to go less than 1 because we're needing a vertical compression because it's not going to go very far. So let's see. Well, that's 4/10. That's 3/10. So I'm thinking, let's do it again because I just accidentally hit the button. I think it's going to be, it says it's between, so that's 4/10. And then 3/10 is on the other side of it. So half of that. So I don't know, let's try it. And this sounds weird, but 3.5/10. Let's see what that looks like. I don't know if we can do that, but we'll try it. 3.5/10. That's pretty nice. To me, that's almost 1/3 though. So let's go 1/3. That's pretty darn close. And so that's what I'm going to stick with for my equation. Okay. Now we're going to talk about what domain looks like, and domain in this scenario. Okay. So the domain, if I put that here, let's capitalize that. All right. It's going to be from -5 to 5. So -5. Darn, I keep hitting that wrong. And then let's go and let's just get this calculator here. -5 is less than or equal to X, which is less than or equal to 5. Okay, that's our domain. Then we come down here and our range is going to be, now she's starting up here and it's hitting the plants. So on our equation, it looks like she's starting at roughly 5 feet and then it goes up to 8. Let's see in the equation what she tells us. They're 4 feet above the ground. Okay, so it's going to, our range, so even though she starts here roughly at 5 feet, it's hitting them at 4 feet. That's where it's splashing on them. So our range would be from 4 to 8. So we'll put that down. 4 is less than or equal to Y, which is less than or equal to 8. And that is our domain range, and that answers all of the questions with regard to 2-81. Oh, goodness. What am I doing there? Sorry. Okay, there we go. And now I'm going to end this before I go crazy. Bye. Okay, so this is 2-82, and you're going to have a couple little videos to go with it too, but I thought it was really important to also solve these algebraically. So yes, we do have a picture of the graph, and you're going to see how we got there. But let's do the factoring algebraically first. So I'm going to set it equal to 0, 2x squared plus 3x plus 1. I'm going to use my fancy little diamond method, even though this doesn't look much like a diamond. All right, so remember it's AC on the top, so that's 2 times 1, which is 2. Adds up to our B, which is 3. So the two numbers that multiply to 2 and add up to 3 are 2 and 1. So I'm going to go ahead and break this apart. And remember, those two add up to that 3x plus 1. Now I do what I call factoring by grouping, where I break the equation in half. And so then I'm going to factor out a 2x, which leaves me with an x plus 1. And if you're ever confused, just redistribute it and you'll see what it is. Okay, so then we have x plus 1 over here as well. And that means this has to be plus 1. So x plus 1 is one of the factors. And so I'm just going to cross it out and see what's left. And that's 2x plus 1. Okay, so in this case, x equals -1. So that means our x-intercept is -1, 0. And in this case, x equals -1/2, because remember, it has to evaluate to 0 in those parentheses. So that means it's -1/2, 0, which if you look up here, that's what we have in our drawing, okay? Now, it also asks us to find the y-intercept. And so if we're finding the y-intercept, that means our x has to be 0. So 2 times 0 squared plus 3 times 0 plus 1, okay? That means y is going to equal 1, so our y-intercept is 0, 1, okay? And these are all going to be, and these are our x-intercepts. And so now we're going to go ahead and prove those using the E tool they gave us, and then also how to find the vertex using your Texas Instrument calculator, because I think it's a very powerful tool to help you with as you go farther into math, beyond Algebra 2 to pre-calculus and so on. So let's jump into those. Okay, so this is 2-82, and I pretty much got a lot of things already on here. You saw a picture on the actual screen that showed what the vertex was and the zeros. But let's talk about all of those really quick. Okay, so this is the graph. It asks us to find the x and y intercepts. So if I come down here, I have, this is one of the x-intercepts and this is the other. We also have our vertex down here at -0.75, -0.125. And we have our y-intercept at 0, 1. So I'm just going to go ahead and I've got all these points plotted, okay? And then I'm going to come down here and I'm also going to 0, 1 is our y-intercept. So I'm going to go ahead and put the label on that. -0.75 and -0.125, that is the vertex, but we're also going to show that in Texas Instrument and a TI calculator so you understand how to actually find it precisely. And especially on a tool like the TI, which you're going to be able to use all the time. Then we had to come up with, what is our axis of symmetry? Well, if our vertex is -0.75, -0.125, the y value serves as the minimum here because this particular parabola opens up. And -0.75, that equation x equals -0.75 is our axis of symmetry. Okay, so that answers all of the questions with regard to the eTool helper. And then you're going to now watch the TI little video as well. So here we go. Okay, so we're using the Texas Instrument calculator to calculate the vertex for this. That's all I'm going to use this one for. I could find the zeros, but we've already done that algebraically and proven it on Desmos. So, but I wanted you to be able to use this tool also. So on the TI calculator, you'll see I've already gone to y equals and typed in the equation 2x squared plus 3x plus 1. Now I'm going to hit the graph. You will also see that I adjusted the window so that I'm going from -5 to +5 on the y and -5 to +5 on the x. And that's just because it's so close to the x-axis. I want to have a little bit of room. So then what I'm going to do is I'm going to hit second, and you've got this little word up here that says calc. So it's the trace button, and that means it's going to calculate something. And I want to calculate the minimum because our parabola is opening up. So I'm going to hit 3. All right. So what I need to do now is I need to go a little to the left of where I think, I know center's somewhere right here. So I'm going to go a little to what I think the left is, and I'm going to hit enter. Then I'm going to go a little to where I think the right of the vertex is, and it's so hard to do that on this because it's so close. All right, but we're going to do that. Then I'm going to hit enter, and we're going to see what our vertex is. Interesting. So it's a -3/4. Well, it says -0.75, which is -3/4. Then essentially it's a -0.125 because we're going to round that. So -0.125 for our y. Okay, now that we've done that, what I want to go ahead and do is show you a tool because this is going to help you on this problem, especially on 2-8.3 where you're going to need to change the vertex a little bit. Okay. So I'm going to go totally out of here because I want to figure out what is my fraction for -0.125. So I'm going to type it in. Then I'm going to hit this math button. And I'm going to hit 1. And see what's going to happen is if this is not an irrational number, which it is, it's a rational number, it's going to give me a fraction. See, it gave me -1/8. That's really important for the next problem. So we have -3/4 and -1/8 as our vertex. Okay, moving on. Okay, so for 2-8.3, it says change the equation in problem 2-8.2, and that was 2x squared plus 3x plus 1. And that gave us a vertex of -0.75, but that is, which is -3/4. And then we also did on that TI calculator, we figured out that -0.125 is -1/8. Okay, so essentially all we have to do is move the graph up 1/8. Okay, so all we're going to do is add so that's going to be 2x squared plus 3x plus 9/8. Okay, and that will give us our new equation. Let me put y equals here just so it all makes sense. So we're changing from here to this equation to get it on the x-axis. Now let's take a look at the graph to prove that we did that correctly. Okay, so this just continues this is just showing you that both of these equations, the way I've written them, as I wrote them right here, are the same on this graph here. And if you notice, we are at -3/4, 0. So that is touching the x-axis at one spot, and that's what they asked us to do. So now that you know how to do that, we'll move on. Okay, so for 2-8.4, I actually went through and just worked the problems, and so I'll go through them quickly. But on this one, my highest perfect square was a 4 that was a factor of 24. So I rewrote it as 4 times 6. I took the square root of 4 out and put it here. So it's 2. And then the root 6 is what's left. So 2√6 is your final answer. On part B, I did the same thing where I broke it down. The highest perfect square that's a factor of 18 is 9. So I did 9 times 2. I took the square root of 9 out, and that's why it's 3. And then what's left behind is root 2. So the final answer is 3√2. On part C, this is like adding two x's. You can't really combine. You can't say root 3 plus root 3 is root 6. That doesn't work. So it's just root 3 plus root 3 is 2 of them. So it's just 2√3. Then you'll see on part D, I broke each one down individually. So on square root of 7, the highest perfect square that's a factor is 9. So I broke that down. So I got 3√3 on the first part. Then on the second one, I also found the highest perfect square was a 4, which the square root of 4 is 2. So then I have 2√3. Then all I'm doing is combining like terms by adding 2 plus 3. So that's why 5√3 is the final answer on that one. Okay, let's move on. Okay, so on here it says below are two more situations that can be described using exponential functions. They represent a small sampling of the situations where quantities grow or decay by a constant percentage over equal periods of time. So we've been asked to do these things for both A and B. So find an appropriate unit of time. So on the first one, the appropriate unit time is years because it says per year in the equation. Find the multiplier that should be used. Well, it's a depreciation, so it's going to be 100% minus 0.11. So our multiplier is 0.89. Then our initial purchase price is $12,250. So when we put that equation together, we start out with our f of x and then our starting point times our multiplier raised to the x, which is years. Okay, and that's our equation for part A. Part B, they're asking us, again, find an appropriate unit of time. So you'll see I used months. Then because you're compounding this monthly and x is dealing with years, okay, time in years, that's really important to put too, time in years. You're going to need to divide your 0.06 by 12. Then that gives you the number of 0.005. And so that's going to be the multiplier that we put into it, 1.005. So that's the tricky part of that one. If it was quarterly, we'd be doing 0.06 divided by 4. If it was annually, we wouldn't have to worry about it. Okay, it'd just be 0.06. But this is compounded monthly, so that does make a difference. Then it says the starting amount. Well, that's $1,000. So let's put our equation together. It's f of x equals our starting amount, which is $1,000, times our multiplier, which is 1.005, to the x. And that is our final equation for 2-85. If you've got any questions, put those in the chat, and I will help you with this one. This can be tricky sometimes to set up these equations when it comes to exponential growth and decay, because there's also compounded interest formulas that are very similar to, and continuous things, which we're not getting into right now, but there can be some tricky questions on this. So please leave them in the chat if you need, or in the comments below, and I'll help you. Moving on. Okay, so 2-86, I just started rewriting them. Okay, so when we have a fractional exponent, the denominator is your root. So that's why we have the fourth root. And then the 5, the numerator, is attached to the number that goes under the radical. So you can see it's 16 to the 5 fourths. Okay, that's how you rewrite it. Well, then I did 16 to the 5th on the calculator, and I got 1,048,576. I took the fourth root of that, and I got 32. If you're using a TI calculator, you need to type 4 first, then hit the math button, and you'll see on the menu there that they have a radical with an x root. And then you can pick that and then just type the number here that I have into it, and it'll give you 32. Okay. The second one on part B, I saw this 1/2, so I know it's the square root. So I rewrote it as the square root of x to the 5th, y to the 4th. I broke apart all of these because I'm looking for square roots. So x squared, and x would all be x to the 5th. Then y squared and y squared would be y to the 4th. And then I took each one out. So as I finished them, I brought them down here where you can see my arrows pointing. So I've got an x and an x, then a y and a y, and then this little single x all by itself is still under the radical. And then, of course, I'm multiplying x times x and y times y, and that's why I get x squared, y squared, square root of x. Okay, part C, the fact that they put a 0 here made that so easy. Okay, anything to the 0 equals 1. So this whole set of parentheses just equals 1, which you see that I pointed here. So I've got, then what I'm doing is I'm moving this to the denominator because it changes it to y to the 1st. So I have x squared over y times 1. Well, it's just x squared over y then. And that's all there is to 2-86. If you have questions, again, leave them in the comments and I will help you. Thank you so much. Moving to the last problem for this, because 2.2.1 has 2 days in it. So we'll move on. Here we go. All right, so you can read through this whole equation. So Harvey's Espresso Express, a drive-through coffee shop, is famous for its great house coffee, a blend of Colombian and mocha java. So they go through all this and they describe everything that they need. The spy returned with a torn part of an old receipt that showed only the total number of pounds and the total cost. So that's this right here. That's key information. Also, the fact that it's $4.89 per pound and $5.43 per pound for mocha java. You'll see here I've defined 2 variables. X equals the number of pounds of Colombian coffee and Y equals the number of pounds of mocha java. So I have 2 equations. I'm setting up a system of equations. So my first equation is figuring out this is for pounds. Okay. And then this equation is for revenue. Okay. but I need to use both of them in order to help solve for the equation. So x plus y equals 18 means whatever x and y is adds up to the 18 pounds in the actual problem above. Then you multiply 489 times x because that's the cost of each pound of Colombian coffee, and 543 times y because that's the cost for a pound of mocha java. You multiply all those together and it gives you the revenue, which they've given you up here as well, which is 9207. So what I did is I isolated y, and then I used that 18 minus x to substitute into the equation. Then I distributed this to both, and that's why you have this equation right here, okay? Then what I did is I combined like terms, which is the 489x and the negative 543x, and I subtracted 97.74 to the other side. So I ended up with negative 0.54x equals negative 5.67 divided by negative 0.54 and got 10.5 pounds. So that is the number of pounds of Colombian coffee that was purchased or that was used, okay? Number of pounds of Colombian. I'm just going to leave it at that. It's kind of messy. Okay, so then when I plug it back into this equation and substitute it in for x, I get 7.5, and that's the number of pounds of mocha java. Hopefully that helps you. And I've got a summary statement right here. So Harvey used 10.5 pounds of Colombian coffee and 7.5 pounds of mocha java. And that ends this question. It also ends our review and preview for day 1 of lesson 2.2.1. Remember, if you have any questions, you can put them in the comments. I'm happy to help with the math, answer any questions you need. Also, if you like the video and you learned something from it, please subscribe and please consider giving us a thumbs up. And thank you very much, and we'll see you on the next video.